Hi, I'm Reggie York. This is a presentation on using the Pearson correlation coefficient to examine the relationship between two interval variables, that is to say, two variables measured at the interval level. At the end of this presentation, you will be able to employ my Excel file for calculating the Pearson correlation coefficient when you want to know if two interval variables are related. You will know also how to use the file to determine the value of the correlation coefficient, presented as R equals and a number, and the value of P, which will help you determine statistical significance. This means that you have data for a group of people that measures the two variables at the interval level. You have two variables, each is measured at the interval level. You wish to know if there is a positive or negative relationship between the two variables. We're going to talk about positive relationships and negative relationships in a moment. Here's an example. You measured 20 clients on age, measured in years. That would make it interval. But if it's just above or below 20, that would not be interval. Interval would be measured in years. And scores on a self-esteem scale. In this example, higher scores represent higher levels of self-esteem. Always be careful about that when you're doing research. So you have two variables, each of which is measured at the interval level. If you find a positive relationship that is statistically significant, then you would have evidence that older people have higher self-esteem. If the value of the correlation coefficient is negative, it will be presented with a negative sign, as illustrated there, R equals minus 0.38. If positive, there is no sign before it. I'll talk a little bit about what these coefficients mean in a moment or two. Let's look at types of empirical relationships. No relationship between two variables. In this case, R is 0, or not very far from it. Positive relationships, which means that those higher on one are higher on the other. If there's a positive relationship between age and self-esteem, that means that older people have higher self-esteem, younger people have lower self-esteem. Negative relationships means that those higher on one are lower on the other. You would expect, for example, that you might expect that higher scores on depression would be related to lower scores on, say, grades in school or something of that nature. The strength of the relationship is an important consideration. The higher the value of R, the stronger is the relationship. Correlation coefficients can range from a low of 0, which means no relationship, to a high of 1.0, which means a perfect relationship. Coefficients of 0.7 or higher are considered strong. Coefficients of 0.4 to 0.7 are considered moderate, while coefficients under 4 are considered weak. This, of course, is a matter of opinion. There's nothing scientific about that breakdown. It's just a matter of opinion by the experts. Now let's look at some illustrations. Here is a file that shows a positive relationship that is perfect. Let's look at this data. Stressors and health problems. On the left side, you see over here, number of stressors. 0 stressors, 1, 2, 3. Stressors, let's say, are things that cause you stress, such as having a marital breakup, having been arrested, having had a serious health problem that put you in the hospital for months, or something of that nature. These we call stressors, and you see a scale over here. They can range on this particular chart from 0 to 6. Over here, you have number of health problems in the past year. In this particular case, it's 0 to 8 on this particular scale of data that we have. Look here, we have, see, John, right here, has 0 stressors and 0 health problems. Jane has 1 stressor and 1 health problem. So as you see, as you move up here, there is a perfect relationship between the two variables. The more stressors you have, the more health problems you have. And that relationship is perfect. You almost never find a perfect relationship. If you find a correlation coefficient that's 1.0, you need to look at it again because you probably have made some kind of mistake. This kind of relationship is almost never the situation. There'll be a few people out of sync here. So the more, this is a pattern that's not exactly straight, but mixed up a little bit here, the more of that you see, the lower will be the correlation coefficient, the lower will be then the strength of the relationship. Here is a perfect negative relationship portrayed as R equals minus 1.0. Marital counseling sessions and marital conflicts. Here we have sessions. How many sessions did you go to? 0, 1, 2, 3, 4, 5, 6. How many marital conflicts have you had in the past month? 0, 1, 2, 3, 4, 5, 6, 7, 8. Here we have negative relationship that is also perfect. Bart had 6 sessions. He had no marital conflicts. Go all the way over to Blake. Blake had 8 marital conflicts and no marital sessions. So this shows a perfect relationship between how many marital counseling sessions you had and the number of marital conflicts. That, of course, is silly because marital counseling is not that effective. But I'm just illustrating the point about a perfect negative relationship. Let's look at number of fruits eaten and marital conflicts. How many fruits did you eat? How many conflicts did you have? Look at the people all over the board. There's not this perfect relationship, a pattern that goes up this way or down that way. It's just all over the place. This suggests that there is not a relationship between the number of fruits you have eaten and the number of marital conflicts you have had. Let's look at statistical significance and practical significance. If you looked at some of the other of these presentations, you've already gone over this. Statistical significance tells us how likely our data would occur by chance. Practical significance is an opinion about the extent that our data is noteworthy. It's difficult to have practical significance in the absence of statistical significance, given the basic meaning of failing to find statistical significance. The value of P tells us about statistical significance. Practical significance lies in the strength of the relationship. A coefficient of 0.73 has more practical significance than a coefficient of 0.52. Now, when you're looking at just one coefficient, however, which one would represent practical significance is a matter of opinion. If you square the coefficient, you get the percent of variance in one that is explained by the other. That's a different lesson, but it tells you a little bit about practical significance. It tells you how well, for example, a 0.5, if you square it, would be a 0.25. It means that a correlation coefficient of 0.5 says that one of the variables explains 25% of the variance in the other variable, meaning 75% is unexplained. Now you're ready to use the Excel file. You'll need to load that file. Then you'll load the you'll load the Excel software. Then you'll load the Excel file entitled Your Pearson Correlation Relationship of Two Interval Variables. You will enter your data and find the value of P and R. Now let's look at this particular file. If I can get it on my screen here. Okay. This is the one. It's called York Pearson Correlation Relationship of Two Interval Variables. Instructions say enter the scores for the first variable in the column score 1 and scores for the second variable in score 2. So here's what you would do. 12 and 10, 9 and 11, 5 and 12, and so forth. So as you do that, of course, then you go over here. The Pearson correlation is shown right here, a negative 0.99. That means you have a very strong negative relationship between these two variables, as I just threw those particular numbers in here. This is your correlation coefficient. This is a guide as to what correlation would be of significance. This n refers to the number in your sample. In our sample here, we only have, what, 3. Only 3 people. And that's not. But if you had 4 and a correlation of 0.95, that is significant at the 0.05 level. As you can see, a sample size of 20 and a Pearson correlation of 0.44 would also be significant at this level. So here's your guide as to whether you have achieved significance at this particular level. If you have a table of the Pearson, you can look at specifics with regard to other sample sizes and so forth. Okay, I hope we're clear about what you do here and how you find what you need to find.